This is AQA GCSE Chemistry. We are on a dual award and therefore triple award topic, and we're looking at the periodic table. This is video number 5 in this series. As always, I'm going to recommend that you pause, have a go at the activities for yourself before reviewing your answers. So we'll jump straight in, having a look in this video at the explanation of the trends in reactivity in Group 1 and Group 7. So in an earlier video, we established that Group 1 reactivity increases down the group, and in Group 7, reactivity decreases down the group. So I'm going to go straight in to put those there because we've seen them before. But as we move on to the next activity, we're going to try to work out whether the statements apply to Group 1, to Group 7, or to both. So now you've had a chance to think about that, let's go through. Atoms tend to lose one electron and form +1 ions. That is definitely the case for Group 1. Group 7, absolutely not. Group 2 would lose 2 electrons. Group 3 would lose 3 electrons. And that takes us back to the work that we've looked at on atomic structure. On to the next one, atoms tending to gain 1 electron, forming a -1 ion. Well, that is always true for Group 7. So now let's have a think about this next one. The nuclear charge increases down the group. That's actually true for both of them because you've got more protons each time. You're adding a whole new set of protons as you go from fluorine to chlorine to bromine to iodine, just as you are for lithium to sodium to potassium, etc. The number of protons increases down the group. Well, that's the same question in a different form. So that one is both again. We've already spoken on the previous section of this video and earlier in this series of videos, we know that reactivity increases down the group in Group 1 and it decreases down the group in Group 7. The next two statements are the beginnings of an explanation of why. So atoms lose electrons more easily down the group because there is a greater distance between the nucleus and the outer electron. So we're thinking about something losing electrons. Well, we know that that is true for Group 1. Atoms gain electrons less easily as you go down the group as the atom is being placed in a shell further from the nucleus. Well, we know that in Group 7 we gain electrons to get a full outer shell, so that's true for Group 7. And we've got the question down at the bottom. The atoms get bigger in both. The atomic radius gets bigger in both. Now for the remainder of the video, I'm intending to try to explain that a little bit more fully. You do need to be able to explain with a degree of clarity why reactivity increases down the group in Group 1 and decreases in Group 7. So I want to start off by drawing out lithium and sodium. The electron configurations, lithium has 3 electrons, so that's 2, 1, and sodium has 11 electrons, 2, 8, 1. We can see they are both in Group 1. They've got 1 electron in their outer shell. And we can see when lithium and sodium react, which electron is going to be lost. Now let's compare which of them is going to be lost more easily. Well, on sodium, the outer electron is further from the nucleus. If there's a greater distance between the positive nucleus and the negative electron, that means there's going to be less of an attraction. But there's other things at play here as well. The outer electron is being shielded, it's being repelled by all of the inner electrons. They're pushing it away. And so when you piece all of those things together, we can see that the outer electron is more easily lost. Less energy is needed for an electron to be lost in sodium than in lithium. And therefore, sodium is more reactive. And if you continued that and you went on down to look at potassium also, that would be a bigger atom again. The electron would be further away from the nucleus, so less attracted, and it would be subject to more shielding, therefore less attracted, and therefore less energy needed. Potassium is more reactive. Now let's compare and contrast that with Group 7. So once again, we are drawing out the electron configurations 2, 7 and 2, 8, 7. And in this case, when they react, they are gaining an electron. Now, as you go down the group and they get bigger, the outer shell is further from the nucleus. Now that means there's less attraction between the nucleus and the electron that's joining the atom. That electron that's due to join is also much more shielded because there are many more electrons in chlorine. And therefore, more energy is needed to gain the electron. So chlorine, more energy needed. Chlorine is less reactive than fluorine. And as you continue down the group, for the same reasons, that trend would continue. That takes us to the end of this video, and that takes us to the end of the coordinated content, the dual award content. The next video, part 6, is related to triple award only. Thank you for listening, and goodbye.